Hi folks, welcome to the series of data structure. In this particular video, we will try to understand what is level order traversal. In level order traversal, we traverse through the tree in levels order. For example, first let us just take this tree over here, example of this particular tree, where first we will traverse through level 0, then we will traverse through all the items in level 1, then we will traverse through all the items at level 2. So what is the basic logic behind it? First, what we will do is we will visit the root node, then while traversing level L, that is the current level, we will try to insert all the elements which are at level plus 1. So level plus 1 is level 0 plus 1, that is level 1. So we will try to insert all these elements to the queue. Then we will go to the next level and visit all the nodes at that level. And the same thing we will repeat, like when we are visiting this node, we will add these nodes to the queue. And when we are visiting this node, we will add these nodes to the queue. So how this works is, initially to the level order traversal function, root node is passed, and what we do is we first of all insert root node A, and then we will try to traverse the node of A. The logic of logic for traversing the node will be like, it will insert the child nodes that is at level 0 plus 1, that is level 1, to the queue. So first it will add B to the queue, and then it will add C to the queue. A is popped out, and we will add B and C to the queue. Now we will dequeue B, that means we will remove B, and we will add the items or child nodes of B to the queue. So first we will add D to the queue, that is this particular node, and then we will add E to the queue. So once B is traversed, now it will try to traverse the next node, that is next node is C. So it will first of all print the data of C, and it will add the items of C, child items of C to the queue. So first it will add F, that is this node, and then it will add this particular node G. That's how now we have traversed. First of all, we have traversed A, then we have traversed the node at level 1, that is B and C. Then we will take out D from here, and we will try to see if there are any child node in D. If there are none, then it will just go to the next node, that is E, and once it will again check whether E has any child node or not. If there are none, then it will go and try to traverse the next node F, and then it will try to traverse the last node G, and we will repeat this step till the queue is empty. So that way we will be able to achieve this level order traversal. Next we will see how this particular logic can be implemented in C#. The same logic can be implemented in C and C++ language also, but I have written the code in C#. I will explain this particular code. You can understand that and implement in C or C++. So I have written a function, level order traversal, which accepts the root node, and I have created one temporary node which I will be using to store the current node, and it will try to process that. Then I have used a queue. Also, I'm checking if the root node is null. If it is not null, then it will go and do the further processing. If it is null, it will just return from this function. So in the step 1, what I'm trying to do is, this is the step 1. I'm trying to insert the root node to the queue. So what I did just now, first node I inserted to the queue. that is root node A. Then in this while loop, what I'm trying to do is I'm trying to take out the first item to the temp variable. So that means I'm just taking this thing out and putting it in temp variable. I'm printing the data of A, data of this particular node, that is A, and then I'm checking whether this particular node A has any left child or not in this step. If there is any left child, it will add that to the queue. So it will just in this particular step, like queue.enqueue, it is trying to insert B to the queue. Here I am inserting C to the queue. Then this while loop is it will go back to this while loop and it will check whether the queue has items or not. Yes, now queue has 2 items. It will come back, it will take this B to the queue. Sorry, it will take this B to the temp variable and it will try to add the items under it to the queue, that is EF, E and F. If we just go back, sorry, D and E, it will just add D and E. Again the same steps will process. Next it will try to take out C and it will add the child node of C as F and G to the queue, and next it will try to take out D, it will take out E, it will take out F, it will take out G. In this way it will try to process this it will traverse through all these nodes in a level by level order. Now let's see how this code can be checked or tested. So first of all, I have created the same tree structure. We don't need to worry about this code. I have just written it so that we can reproduce the exact same traversal. So I have created the tree structure something like this. I created node 7, then node 6, node 5, node 4, node 3, and under node 3 I have given a left child node as 6, right child node as 7. Under node 2 I have given left child node as 4, right child node as 5. Under node 1 I have given left child node as 2, right child node as 3, and I'm just traversing through this particular function. This is the function. So let's just run through it and see how it is performing. So I just created the tree, then it is trying to traverse through this node, and the root node is 1. So you can see on the right side it will start printing the data. So it first came, it just added one item to the queue, then it took that item back to the temp variable, it printed the data, you can see here 1. Now in the next line it just checked whether the root node's left child has data. Yes, it has. Then it will just add it to the queue. Same thing it will do with the right child also. Now it is going and taking the next child, that is 2. It will print it, and then it will again check whether that has the left child and right child. It will add it, and this way it will print. It will traverse through all the nodes and it will print the data. In the next video, we will try to see we will try to solve some of the problems related to trees and binary trees. And if you like this video, please subscribe to this channel and give your valuable feedback so that I can improve my content and help many other developers. Thanks for visiting.